Good morning. Today we are going to talk about variables, expressions, and programs. Let me go ahead and share my screen with you. We can go ahead and get started. So last time we've been learning the basics of programming, and we have started to see how to put programs together. And what we're going to talk about today is we are going to learn about how to assign variables, what an expression is. We're also going to talk about how one can go about, sorry, this is not working. There we go. How we can go about setting up expressions and so forth, and just how we can then put those things together to make programs. So those will be our topics for today. This is a bird's eye view of what we'll be covering by section. So first we'll start off with expressions and values, then we'll be doing Python types. Then we'll learn how to do statements and parsing expressions. Talked a little bit about parsing last time, and you've seen some of that on your homeworks. Then we'll talk about overloading, variables, programs, print statements, which are extremely useful, and also comments, how to put comments into your programs. So let's get started with expressions and variables. So expressions and values are something that we can think of in terms of using just a basic function calculator to get the idea. So you're probably pretty used to using, your basic calculator like this one right here. And so we could type, for example, 2 plus 3 onto the calculator. And so the expression, the 2 plus 3, represents data. And when we press the equals button or the enter button, that is going to represent the evaluation when we're asking the calculator to go ahead and tell us what the answer is. And so that is then going to parse the expression and return a value that is then reported back on the screen. So we're quite familiar with this sort of thing with 2 plus 3, press the equals button, and 5 will show up on your calculator. In Python, this is what it's going to look like. So you've seen the Python interactive interpreter last week. So here we are in the interactive interpreter, recognizable by these 3 greater than or chevron signs. So we enter 2 plus 3, which is the data, and then we press the enter button, and that causes Python to evaluate the expression and to return back the value of 5. So the value is equal to the original data. The value is going to be expressed in canonical form or lowest form. Python can evaluate expressions, and Python in interactive mode is going to interactively evaluate the expression and display the resultant answer on the screen to you. However, it would not show it back to you if you did it in the script, and that is why we will be learning about print, so that you'll actually be able to see the answer. So in order to be able to carry out this procedure, we will need to have some sort of an expression language. Python will need to be able to interpret what information you're providing. So we're going to need to have integer and float values, arithmetic, numeric comparisons, Boolean values, and Boolean logic. So let's take a look at what each of these components actually means. So in a simple expression language, you might agree we need to have some numbers. Okay, so what are the different kinds? There are in fact a lot of different kinds of numbers, which you might learn about in your math class and some of the number theory. We don't need to really get into that too much. Basically, we need to have different ways of representing the numbers. There are 2 essential ways, that is the integer values and the floating point values, depending on whether or not we need to have the decimal component to it. So I'm sure you're all familiar with the integer values. They include the negative integers, 0, and the positive integers, and this is typically what students get on their number lines. And then we would need to have floating point values, which can be used to represent these other things that are requiring decimals. Of course, an integer could be changed into a float, and it would be equivalent in terms of, 1 is equal to 1.0 in the extent of it means 1 item, but the way that it is mathematically the way that it's stored in the computer's memory is different. And this is why we differentiate between the integers and the floating point values. So floating points can be used to represent these various types of numbers. So you're probably familiar with some of these. The rationals usually comes up when you start doing fractions, because converting fractions to decimals, as you know, some of them do not have easy solutions, that they're terminating, non-terminating decimals, and so we need to have some representation of them. Real algebraic, okay, we can again have, you know, things such as the square root of -2 and so on in the real numbers. And of course, there's an infinite number of numbers in between any two given numbers. And so this is why we need to have the floating point values. Our simple expression language will also need to have some functions that we can carry out. So on our typical 4-function calculator, we're used to having the plus and minus, multiplication and division symbols. We are going to have an additional kind of operation that we can do, and that's going to be called floor division, which we'll talk about shortly. That is basically getting the whole number answer to a division problem. We'll also have the exponential symbol and the remainder symbol as one of the functions we can carry out. There are, of course, many more things you can do in Python, and many of these you will encounter when we get to math, which is a library you can bring in that will do many more things. But we're just talking about the basics. We also have equality and inequality expressions in Python. So we want to be able to do numeric comparisons: less than, greater than, less than or equal to, greater than or equal to, is equal to, and is not equal to. Okay, this is always a point of confusion. The double equal sign is asking the question, is something equal to something else? When we have the single equal sign, that is going to be to assign a value, right? But all of these things are going to yield expressions that could either return true or false. So we're asking, are these things equal? Are these things not equal? Is the expression on the left greater than the expression on the right? So these kinds of symbols are used when we are trying to ask the question, is something greater than, is something less than, or so forth, than something else, and they will return a Boolean, which is a true or false value. Speaking of which, we need to have the Boolean values in order for our simple expression language to work. So the Boolean values are true and false. Pretty simple. There's two choices. We do have the Boolean logic, and so this means we want to be able to use and, or, and not in our actual expressions. So we could say, are A and B both true? So then we would say that A and B are both true in this. So this is a Venn diagram to represent this when we have this shaded region, right? So the Boolean and, or, and not are allowed in our expressions. Let's just take a closer look at the floating point division versus the floor division. This is oftentimes a point of confusion. So the single slash is going to be the floating point division, and is probably what you're expecting when we're talking about divided by, right? So this is regular, ordinary division when you're going to compute an answer and report some either fraction or decimal answer is your response. So just as a quick reminder, we have the dividend is divided by the divisor, and the quotient is given on the top. This is the division symbol. This is typically what we use in the schools in the United States. I know there are some representations that others may have encountered in other school systems, but hopefully you can follow along pretty simply with what's happening here, right? To work out the division problem here. And so this is the representation we would have. So if we do 692 divided by 4, which is this problem right here, the answer is going to be 173.0, right? Because there is no decimal part to the answer because we have a remainder of 0. And so when we do regular floating point division, one thing we want to note is that Python will always return the answer as a float. It will always have that decimal component. Here's another example. We have 128 divided by 5, and this has a remainder of 3, which can be converted into the decimal part of it. And so that decimal part is the 0.6, right? And so the double slash is going to do the floor division, which we're now going to contrast with the floating point division. So basically what the floor division is going to do is it's going to return the whole number part of the quotient, and only the whole number part. No, none of the remainder and none of the decimal part if it exists. So this will tell the whole number part of the quotient. It does not report the decimal part of the quotient, and the result is always reported as an integer. So we can tell this apart, the 692 divided by 4. So even though it's numerically equivalent at 173, this one is reported as the float and this one is reported as an integer. So floor division will always be reported back as an integer, because when Python is trying to calculate this, it always knows that it will only need to report an integer. Whereas when we're doing floating point division, think about it like this. Does Python know, when it only has the inputs, whether or not the result will have a decimal answer or not? And the answer is no, it won't know that. It could know that from adding 2 digits together. So if the input is 2 ints, we know that the answer to addition will be an integer. Same with subtraction and multiplication. But in division, we don't know whether or not the answer will be an integer, or if we'll need the float to represent that answer before we get started. So it's automatically going to report the answer in a float when it's doing division for that reason. Okay, and now we have the 128 divided by 5, which has a remainder of 3, and again, it's going to report the whole number part, which is clearly different from this example here, right, where it's 25.6. We're only getting the 25, the whole number part. So suppose you wanted to know what the remainder is. So this is when we use the percent operator, which is going to extract the remainder from doing the division problem. So 692% 4, there is no remainder, so this will report 0. 128% 5 is going to report the remainder of 3. So the answer to a division problem can be expressed using the remainder. So we can use the double slash to get the whole number part and the percent part in order to get the remainder. So if you wanted to, for example, get back the answer in the format of the whole number, remainder, and then how much, we could use this, an example like this. So I know we're still going to be looking at print in the future, but I think you can follow along with this, right? So we're going to print, and then it's going to tell the division problem. And now we're going to do the floor division to get the whole number part, remainder, and then it will give you the remainder part right here. And so when we do this in Python, it will express it back to us just like this. The green part's coming down here because they're literal inside the quotes, and then it's filling in the answer. So we get 25, remainder 3. So this is how you could do that. The percent operator is useful for testing divisibility. So if the dividend is evenly divisible by the divisor, the percent operator in that division problem will return 0. So if you want to test for divisibility by 2, for example, we could see that 100% 2 gives back 0. So now when we get to doing the if statements, you see that we could set up an if statement to test whether or not something is divisible by 2 using this test. This brings us to Python types. Now we've been talking a little bit about this in a sort of an ad hoc way, but we need to talk about it in a more deliberate way. So what is a Python type? Well, there are different types of data and they have different attributes associated with them. It's useful to have different types, each with their own associated actions. This is part of the object-oriented approach to programming inherent in Python, because you'll be learning how to create your own types. And so the types we have seen so far are ints and floats. So consider storing the text DOG for dog and 3.14, which is a floating point. So one is text and one is a decimal. So what other kinds of data might one want to store? Are there other types? Well, integer might be one of them, for example. And then we want to think about what actions we want to do with each type. So for example, we might want to do math on numeric types, but that wouldn't really make sense on text, such as a dog, right? So what we're going to do is we're going to have different types associated with the different kinds of things that we can store. So we'll need to have some types associated with the data. So let's talk about it in a little bit more detail. So types are able to classify expressions. The type of an expression is always the same as the type of its value. So sometimes we'll encounter today are going to be the integers, the floats, the strings, and the Booleans. And these aren't the only types that are in Python, and we'll be learning more types as we progress through the course. And when we get to object-oriented programming in our one of our very last lectures, we'll talk about how you can create your own. So one of the things we might want to do is we might want to check the type using Python. So we can say, Python, what is the type of this expression? So the syntax for this is type and then expression. So just as an aside, when we have an example of the syntax, I'm going to use some notation that you should become familiar with, so you know what you literally need to type on into the computer, and then also what is the part you should fill in. So you would use the keyword type, which we see down here in this example. You see it's turning this nice purple color. This is indicating that it is a keyword in Python. So we would literally type the word type, and now you see that we also need the parentheses. But these angle brackets are where I'm going to put in a description of what you need to fill in. So this is the variable part right here. So you'll use type, and you'll literally type the parentheses, and then you put an expression in. So in this example down here, the expression is the number 3. And now it's telling us back that the class type of this is int, for integer. Now let's try a couple others. 3.14 is a float. Here is a string, which is the text. So string is the word we use to describe something that is a literal text in Python. You see that it's enclosed in quotes, and there is a space in here, which is part of it. This does not cause it to break into 2. It's whatever is inside that string. And we also have the Boolean. So for example, true. Notice that this is typed with a capital T. Notice that it turns yellow color. So this is Python indicating this is a Boolean, and that we do not use the quotes on this, because if you put it in quotes, it will become a string, which is not a Boolean. So strings are sequences of characters, that is text. To enter a string, you're going to surround it with single or double quotes. Here we have an example of single quotes. Here's an example of double quotes. Notice that there's an apostrophe in this expression, so therefore we must use the double quotes in order to have the apostrophe be part of that string. Strings have the type str or str for string. Integers, as in math, an integer is a number with no decimal or fraction parts. That includes -2, well, yeah, so it's basically negative infinity to positive infinity, the integers, right? And integers have type int. Floats. We've seen these are part of, this is motivated by division. And so the floating point numbers are the variable precision decimal approximations, right? So there are some numbers that are irrational that we in fact cannot express using numbers that we can write because they're infinitely long. So we write a representation rounding to tell us what it is. Computers do not have infinite number of decimal places, although they can hold many decimal places. And they have the type float. Python uses the decimal point to indicate that a number is a float rather than an int. So here is an example of a float. And again, if we do type of 3.0, because that one has the 0 in it, this is in fact the float. So now it's your turn. We have a couple of questions for you to look at. So I would ask you to read this question over and then pause the video to try to answer the question. We're going to look at considering 3 versus 3.0, which is the int and float, and which expression or expressions will have different type than its constituents, and what is the value of the expression. So go ahead and take a moment to do that, and after you've done so, please join back with us. All right, I hope you've had a moment to look at those questions. The 3 versus 3.0, the 3 of course is the integer, and 3.0 is of course the float, which we can verify in Python by showing this here. You'll be doing some exercises like this in the lab. Which expressions have different type than their constituents, and what are the value of the expression? So here I've broken out the answers for you, giving you the first number and the second number and the answer that will come out, and I've also given its type. So we can see from this that 5 and 2 are both ints, and this is double slash. So this is going to give back only the whole number part. This is floor division, so that's 2 is an integer. 7 divided by 5 is going to be 1.4, the float. We have 16.0 divided by 4.0. These are both floats for input, and we get out 4 for the answer in float form, because division always gives us a float. And now we have this expression here, 16 divided by 4, right, is also the answer is 4, right? But curiously, Python gives us 4.0. Why is that? That's because what I was saying about Python not knowing ahead of time with what the input is, what the output type will be from the input. So it needs to decide which actual code is it going to run. And so because Python would not be able to distinguish whether the answer will be float or int before it does the problem, it will calculate all of them using float. So the idea here is that Python has code that it actually executes when you type the expression, right? You type the operator plus, right? It needs to decide, does it need to run the code that is for the plus for integers or the plus for floats, because they'll be different. That's really what, when we get into object-oriented programming, that's really what you're doing when you're creating the object, is designating the code that it should run under that situation. And that's what overloading is, which we will talk about in a moment. All right, so we also have Booleans. Booleans have the value true or false, the symbols to evaluate the Booleans are summarized here for you. So here is some examples of some expressions, and you can convert those into words and then evaluate those to true and false. So true is less than or equal to 3, which of course is a true statement. This expression here, the exclamation point means not. So 2 is not equal to 0 is also a true statement. Again, remember the equals is to compare between them. So we're asking the question, is 2 equal to 2? And the answer is yes. So this brings us to the Boolean truth table. This is how Python looks up the answer. So inside Python, there somehow needs to be some answer table. So when parts of an expression evaluate to something, that it knows what it should return. And that's what the truth table does. So in the truth table, it's like the cookie jar example. So let me tell the cookie jar. Suppose there's a little kid. I'll be the little kid, and suppose nobody was looking, and there was a cookie jar sitting out on the table, and nobody's around. So I said, okay, well, I'd really like to eat a cookie. So I go and I open the jar and I take out a cookie and I eat it, and nobody saw me do it. So I think I got away. And just at that moment, my grandmother walks in the room and says, have you eaten a cookie? I see that there's one less cookie in the cookie jar. Did you do it? So then I'm in the situation of what am I going to say, right? So I could say, yes, Grandma, I ate the cookies. And so that would be a true statement. So the truth table would evaluate to true because I told only the truth. But what if I said, well, Grandma, an alien came down from space and told me that I could eat the cookie, and so I ate the cookie. All right, well, now we have two parts of that expression. We have the alien part and we have the I ate the cookie part. So that would be a false and a true. So is my statement really true? No, it's false because part of my testimony is not correct, right? So it's like that with the truth table. You have to tell the truth and the whole truth and nothing but the truth in order for it to be true. So if we look at it like this, the only way this will evaluate true is if you always tell the whole truth. If you tell part of the truth, the aliens came down and told me to do it, that part is false. But if I say, and I ate the cookie, that part's true, but that doesn't make my story true, so that's still false. Same thing as if I tell the fib first and then tell the truth, that's also false. And of course, if I say, nope, I didn't eat the cookies, if everything's false, then of course the expression is false. Some things to note about the Boolean types, they all begin with capital letters, and Python is case sensitive. Also notice that they are not in quotes, because if they get put in quotes, they become strings, and that's not a Boolean. So this is just to summarize the Python types that we've seen so far. We've seen strings, integers, floats, and Booleans, and here's just a brief example of each one. And we will have many more types throughout the course. This brings us to compound expressions, which we've kind of alluded to. Compound expressions may involve expressions of different types. When the expression is evaluated to its value, the type of the value will depend on the types in the expression, and then the expressions are parsed using order of operations. So we've seen this a little bit when we were talking about those math expressions and looking at the input. So we've seen some mixed types, like if we had 16.0 divided by 4, that's mixed types, and then the question is, well, what will the type of the output be? But it could be more complicated than that, because it could involve strings and so on. So some examples of checking the type of compound expressions using Python is, again, we can simply just use the type keyword, and then we can put our expression right in here. So this is how you could test that. So this is fairly straightforward, that these are going to be integers, but here we have the mixed type like we were just talking about. So this 4 minus 2.6 needs to convert the 4 to a float before it can complete the subtraction of 4.0 minus 2.6, which is what Python will in fact actually do. And then this is an example of a Boolean. So now we're going to talk about statements and parsing expressions, and this is why we had you do some parsing in your homework. So a statement is an instruction to perform some kind of actions. When Python executes a statement, it performs the corresponding actions. There are going to be observable changes caused by those actions, which are termed effects. So, for example, taking user input from the keyboard, printing the text to the screen, drawing a picture, which we'll do with turtles, saving data to a file, and many other things. The central role of statements is what makes Python be that imperative programming language, the programming language which follows the instructions of the program that the user writes. In Python, there is a statement that does nothing, which seems a little bit strange. We have pass, and that statement is used as a placeholder. It may seem useless, but sometimes we need to provide a statement even though we don't actually want any action to occur. So what we might want to do is write some expressions in words and then parse the expressions and evaluate and give the type. So take a moment. This is similar to what we've been doing all along. So go ahead and pause and let's do a quick check on this. All right, welcome back. So we can write these expressions using words. The remainder 16 divided by 7. The result of 3 to the power 12 is evenly divisible by 4 this many times, and 22 divided by 7. So then we can parse the expression and evaluate, which is similar to what we've been doing before. And so you can see that the answers are integer 2, and 3.14, and so forth, expressed as a float. So this brings us to overloading, and this is what I have been alluding to when we've been saying that there are different actual pieces of code inside Python that will evaluate things when we have different types for the input. So the arithmetic and comparison operators are overloaded to act on floats. So 2.5 plus 3.5, 2.5 is less than 3.5, right? So these are some of the arithmetic operators. Overloading is when different but conceptually related operations are given the same notation. So we're talking about the actual operator here. The symbol here is going to be the same, but the actual code that's executed will be different. So when we're adding two floats together, The way the Python actually does it is using a different code than when it actually adds together two integers. This is just for our convenience because under the hood, the codes are in fact completely different. They're different. In fact, they're different code blocks. The types are used to tell them apart. So that's how Python knows which of those to run. An expression gets more complicated as we put various parts together. And so it's going to become increasingly important to keep track of their types. And when we get to functions, we will in fact explicitly be recording what the types of our inputs are. Okay, the strings, again, are going to be the sequences of characters, and we have overloading with the strings using the plus for string concatenation. This means that we are going to have plus mean something for strings. So obviously it doesn't mean the same thing as 2 plus 2. What's it going to do? Well, what it's going to do is it's going to join them together, and this is called concatenation. So if we have py plus thon, we're going to get Python, and here I'm showing you what it looks like interactively. We also have overloading using the multiplication symbol, which is the star, and that is going to be string repetition. So if we have Python *3, we see that it is going to replicate Python 3 times. So here are some more examples showing overloading. So here's overloading of plus for strings. So you see that I've set up some variables to be equal to various strings, and we have a secret message here, so you can check me to see if you agree that this is going to give have a great day, right? And we also have the 3 distinct uses of plus that we've seen so far. This is integer addition, this is float addition, and this is concatenation. So notice that the 3 and the 4 are being represented as strings here. They're not their numeric values, which we notice because they're in the single quotes. So those are going to become concatenated to give us 34. So to more formally introduce variables, variables are names that refer to values. So rules for variable names is that they may contain only letters, digits, and underscores. They cannot begin with a digit. They are case sensitive, so if you have something started with a capital letter and another time you use a lowercase letter, it's not the same thing. They are distinct variables. They should not be any of Python's keywords. So in fact, it's actually possible to set variables using Python's keywords, but it is definitely not advisable to do so. So this is some examples of variable assignment. A equals 2. This says A gets the value of 2, B gets the value of 2.0, C gets the value of the string cat, and D gets a Boolean false. Here's an example of using a keyword as a variable. So print, we've seen the print before, right? And so a student types print equals 1. Okay, well, first thing we should notice is this purple color, okay? And that should be a dead giveaway that that is a keyword in Python, and maybe we shouldn't be doing this. Okay, so let's suppose that we did it, okay? You do print equals 1, and I say, Python, what's the value of print? It says, well, you just asked me to assign it to 1, so the value is 1. And now we go to print hello, and we get this curious message. On line 1, right, we get an error, integer object is not callable, and so now you can no longer do printing. That's because you've changed what print means to be equal to the number of 1. So this resolves to 1 hello, which is not defined, and this is why we have this error message. So please do not use Python keywords as variables. An assignment statement is going to cause a variable to refer to the value of an expression. So we'll type this as variable equals expression. And so here is an example of doing so. We have life, the universe, and everything equals 42. So the value of the variable becomes that of the expression assigned to it. Assignment is not a mathematical equality. And so you'll notice I've been saying gets or gets the value of. And so we don't really want to read this as equals, because really what it says is we are going to assign the value of whatever is on the right hand side into this variable over here. And so this will become apparent as we see that variables can be on both sides of the equal sign, which makes it even more interesting. All right, so when an assignment statement is executed, there are 2 steps that happens. First, the expression on the right-hand side is evaluated to whatever value it will be. And then in the second step, the value is assigned to the variable on the left. So here we have x equals 1 plus 1. So the steps would be 1 plus 1 being evaluated to be equal to 2, and then x is assigned to the value of 2. Now you see that this is a kind of a nonsensical algebraic expression, right? X equals x times x. Like what does this mean? Okay, so what we can do is we need to think about the steps for the variable assignment process to make sense of this in programming speak. So the current value of x is now going to be 2 from the expression above. So now what we say is first we evaluate on the right-hand side. So 2 times 2 is 4, and now x is assigned the value of 4. So you see that the value of x throughout a single program could change to have a new value, and it can update, which we'll talk about when we talk about the variable tables. Speaking of which, here they are. So the variable table can also be referred to as the environment or the state diagram. This keeps track of the values assigned to each of the variables. When you assign a value to a new variable, it causes it to be added to the variable table. So this is going to exist throughout your program. Python doesn't store it exactly like this, but this is a very convenient way for us to express that and to keep track. Reassigning a different value to an existing variable will cause the table entry to be overwritten. So a variable can only be assigned to one thing at a time. So if it gets a new assignment, it crosses the given one off, and then it replaces it with the new value. It is an error to refer to a variable that has not yet been assigned a value. This sometimes occurs in students' programs. They have a variable and it doesn't actually have a value yet. So you, of course, have to have a value before it will work. As Python runs a program, it repeatedly consults and updates its variable table to keep track of the program's state. So if you come to me, say when you're working on your final project, and you say, oh, my project doesn't work. What's wrong with it? One of the first things I'm going to ask you is, did you write out your variable table? And oftentimes you said, no, I didn't do it. And I'll say, well, let's write down your variable table and trace out the value of the variables as we step through the program. And so this can be an extremely useful tool for debugging your programs, especially when things are giving answers, but the answer is unexpected. Usually the problems can be found by tracing out what's happening using the variable table. So this brings us to programs. It could be useful for us to just pause for a moment and think about what is a program. I would challenge you to take a moment to jot down in your own words, what do you think constitutes a Python program? And after you've had a moment to put it down in your own words, we'll proceed and take a look at the formal definition. So in Python, a program is a sequence of statements. We can save a program to a plain text or script file to edit or to run later. We'll use Python's built-in program editor called idle for writing Python programs. In this class, you've encountered idle already in your exercises from last week and in your lab. Python script file should have the suffix .py, which will automatically happen if you just use the file save as option. Running a program causes its statements to be executed in order. So unlike the interactive interpreter, running a program from a file does not cause the value of every expression to be displayed. So then the question becomes, well, did Python actually calculate x plus y? How can we make Python actually show us what it's doing? And that brings us to the print statements, and that is precisely what we're going to do. So when you're working interactively, you will automatically see the value being shown on the screen, right? But when you run the scripts, that doesn't happen. And so we're going to need to make use of the print statements to actually do this. So a print statement causes a textual representation of a value to be written onto the screen. Print will provide the resolved value of what it is printing. Print itself is actually not a statement. We say print statements, but really it is actually a built-in Python function. And we'll talk about functions in more detail in our third lecture, in which we will revisit print and talk about that as actually as a function and what that means. But for right now, print is just print. Print only displays strings, and so if we have input that is not actually a string, Python will help us out and try to make it a string. numbers will automatically be converted to strings when they are printed. So here we have an example. So we'll have print, and then we have our parentheses. And here you'll edit whatever it is that you wish to print. So here's a series of print examples. So here we have print, right? And we have a statement here, which now I'm showing you what will happen underneath, right? You could print some text. You could print numbers. So if we do print and we have 5 in quotes, it will print 5. Here we have a variable, which is going to take the value of the expression. So it will first need to evaluate this expression, what happens to evaluate to 42. That will be stored in answer, and then print will attempt to print the answer, realize that it is numeric, and it will attempt to turn it into a string, which it can successfully do, and then it prints 42. Print the value of a numeric expression. So in this example here, you see that we have a numeric expression being stored in a variable, and then we print the variable. In comparison, this one is printing the value of an expression directly, which we can also do. We may have some text and the value of a variable in it. So here we have a variable on the end, and so this will print and the expression that you have here, so the literal text, and then it will insert also the answer. And here we are printing using a concatenated string. So notice that in this example, we're printing 2 distinct things, a long string, which happens to be a sentence, and answer, which is a variable, and they are comma separated. And notice also that it inserted a space automatically because this quote closes with no space at the end, so a space was inserted. We can also use concatenation to have multiple things being put together. So notice that this is multiple things being concatenated together to evaluate to a single string, and then prints that single string. There are no spaces here because the concatenation did not leave any space for there are no spaces here. And so when it concatenates, it doesn't add them. So it automatically adds a space with the comma, but it does not when you do string concatenation. And that's how we get this result here. Comments. So comments are extremely useful to put into your programs. A comment is a text in a program intended for humans and not for computers. The comments are not run by the computer, and thus they are called comments. In Python, the comments start with the pound character and go to the end of the line. So for example, we may have a print statement and then we want to say something over here. So this student was extremely excited about learning Python and felt they needed to comment on that. An alternate style of commenting is with the triple quotes. So in a triple quote, you can open with 3 quotes, and between this triple quote and another triple quote, then that will all be treated as a comment and will not be executed by Python. There are a number of ways that you can use comments. You can use them as headers on assignments to explain some code, to set up the code outline before you fill it in, or to debug some code. This is some tips for how you can use the comments. So notice that the triple quotes can be triple single quotes or triple double quotes. So what I'm showing you here is an example of triple single quotes. So we have 3 quotes opening, 3 quotes closing, and there's single quotes. We can also have triple double quotes, which we have down here. We can use the pound symbol. And notice how in the script it actually is color coding this all for you, which is really quite helpful. So here is an example of a print statement, and here is the string, right? So single quotes can be used for strings. Again, this will be a comment to the end of the line. So here, this comments from this part, and then here it comments from the pound symbol to the end of the line, which so happens to be the entire line. You cannot do mixed quotes. So you can't do double, double, single to say, oh, that's my triple quote. No, that doesn't work. Now, if you have single quotes inside of your triple quotes, you'll need to be careful about that. So if you're a single quote, because you have a string, you want to do your triple double quotes Because the problem is if this were single, 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 that's going to be open, open, open. And it's going to say, okay, oh, close, 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 right? And it may start interpreting this in ways that you do not expect because it thinks you were trying to close your quotes, even though the quotes are not one after the other. Okay, so it's really safer to be using the triple, double quotes just in case you have some single quotes on the inside, which you would if you had any strings in there. So the usefulness of doing the triple quotes is that you can easily remove them if you want to uncomment the code. So notice that if we had taken these triple quotes off, this would in fact actually be active code. So therefore we could use the quoting method in order to block off code during, say, debugging or program development if we didn't want to run that section. You should use comments on your submission, so every script file that you write for this class should have your name, your email, your course number, lab section, and assignment name, number, and date at the top. So here's an example of what a header on your assignment should look like. Here are some examples of using comments in a Python program itself. So I've actually taken this from a task that we're going to do later on in the semester when we actually start writing some short programs. This is from the Caesar cipher, which we will give you part of the code to get started, and then your job will be to finish the code. And so we see that we have some different examples of how the quotes can be used in order to write your program. So for example, here's a header at the top explaining what this is about. This is a function. I know we haven't done functions yet, but you can appreciate that there's some code here, and we're turning off a piece of it, right? Because this is things that are obviously meant to be read by people and not to be read by the computer. So what we can do is we can provide information about the function in the quotes here so that the computer won't run it, but you who has to do the assignment can look at this and say, oh, okay, yeah, I can understand you're trying to tell me some information about what I need to do. And this is that pass we mentioned if you want nothing to happen. This is necessary because we'll need to have something inside our function, and so we put that there as a placeholder, and then the idea is I would give this to you as your assignment, and then your job would be to fill in, right? So you'd delete the pass and you'd actually fill it in with the actual code that goes here. That would be your assignment. Here are here's an alphabet. This is a variable assignment, and this in fact actually is a little function that's already working. It's just a little teeny one, but we have this again, this information to explain the thing that is actually doing. So I put together this little debugging exercise for you. Now, this is one of my favorite kinds of exercises to give you, and you can recognize them because you'll see that there's this fly up here, a bug in the code. So something about this is not working, and you may see a question like this on your exam as well, where I give you some code that superficially may look like it's doing what it says, but something could be wrong. And it's your job to figure that out. Okay, so here's a snippet of code. It's not computing the area correctly. And I have some questions for you about this. So here's this wonderful code. So what's wrong with it? What output do you expect? Try to run it and compare with your expectations. So you should run this code in your head. Think about what will happen, or run it on a piece of paper. What is going to be the output? Try to run it and compare with your expectations. So you have to get an expectation first. You can also then put it in your computer, type it up, and see what will happen. Use the commenting to stop the program from trying to print the area while you are searching for the problem, because you'll notice that this will cause an error. So how could you turn that off while you're working it out? Introduce a print statement to check the values of X and Y and verify that they are as expected. So I would recommend you to put some print statements in here. Based on those results, comment out the old code and write a note why it is not working. So there you can use a comment. Introduce a working variable assignment, and then turn the area print statement back on by uncommenting it and successfully execute the code. So this is a good exercise because it does review a lot of the things we've talked about today. So I would ask you to just take a couple minutes and try to do these things that I'm asking you to do. And then once you've given that a try, we'll reconvene and we'll talk about what is wrong with this code. All right, well, welcome back. Hopefully you've been able to identify the problem. So if we take a look at this code right here, one of the things we have here is that we have y equals, now I have 8 times ty, right? So what's happening is we're getting the tiles, right? So we have x and y sizes, and then what we're going to do is compute the length of the floor in x, compute the length of the floor in y, and then we're going to try to get the volume by just multiplying those single x and y values together. And so the problem happens right here. Now, if you run the code as written, you may be surprised at what you get, right? So the volume is in fact going to cause an error because, as you notice, y has the wrong type. This is a string. And so what is 8 times ty? Well, that's replication, right? So it's going to repeat 8 times the ty. Okay, which may not be really quite what you expected. And the reason is because it's doing that, and we have well, and also this is in the string, right? So this here is literally 8 times ty inside the string, so that can't even evaluate. And now we have x times y, which is going to be the string. So it's completely not doing what we want it to do. So of course the solution is to simply just remove the string here so that you'll get 8 times ty, right, to get your size. So the 8 is from the 8 tiles, and then ty will be 5, so that should be the number 40. And here we fix that problem, and we have 8 times ty, and we get the total volume of the room. So then that brings us to today's summary. We talked about expressions and values in Python, and we've also talked about Python types. We looked at statements and parsing expressions in a little bit more detail than we talked about in the previous time. We've talked about overloading. That is when we use the same symbol and it has different meanings depending upon the context, that is, depending upon the types that are used. We've done variable assignment and talked about how variables take the value of the expression that it is set equal to. We've talked about putting those things together to make programs. We've also mentioned how to display the value of a variable. So if we do it interactively, then it will just come up on the screen. However, if we do it from a script, that will not display on the screen, and we'd never know what the value was unless we had print, which will tell Python to actually put that onto the screen. Finally, we talked about comments, which are useful for information for humans who will be reading the code, your future self, and others that you may be collaborating with. All right, well, I hope you have enjoyed learning a little bit more about Python today on your journey. Looking ahead, we'll have your lab section. So again, for our first 2 weeks, we are online for the labs. So you should show to the one that is your lab time. And we will be giving you information about rotating students in for the in-person sections to start in week 3. We have our TA help sessions, which you can log onto. We have information on our website as soon as that's available for you to know who will be at which help sessions and how you can contact them, whether they are online or in person. Actually, these office hours is displayed here need to be updated because I have class during some of those times. But you can check our syllabus and on the website, and you can see those office hours. So basically, you can see me after the lecture on Tuesday, and I am also having office hour times on Wednesday afternoons. And if those times do not work for you, you can also always email me and I will figure out a time to see you. All right, well, thank you very much. And it is always great to spend time with you. And I look forward to seeing you in the labs on Zoom. Or if you're working remotely, don't forget to stop by and let me know how you're doing on your labs. We'll see you soon.